Welcome, everybody. We are in 2024. Erlang is dynamically typed, and it's type-safe. We all love that. Actually, it has had type annotations since 2005. And if you go on the internet, you will find in the documentation the types and function specifications that tells you what types there are, how they work, how they're supposed to be used. And as the documentation shows, the type information can be used for documenting function interfaces, providing more information to tools, such as Dialyzer. There we also heard about ELP and eqWAlizer, which are great tools. If you don't use them, you should definitely consider trying them. And they're also used for documentation tools to generate nicely looking web pages. So everything is good, right? We're set.
So let's take a look at one example. So sometimes we use functions from the standard library, and one of those cases is the list map function. It's documented like this. We have two arguments, fun and list, and the result is list2. And it just maps from A to B. And sometimes we use these things and we make silly mistakes. For example, when we apply the function, the transformation function for a list of integers, and we specify that we're transforming a tuple, we expect a tuple and apply plus on that. So this is an obvious mistake. It will crash at runtime. And that's why we have tools that use these type annotations that can help us detect such silly mistakes. For example, Dialyzer. Dialyzer is well known in the Erlang community. It's been with us for quite some years. And it's able to correctly identify that indeed this code will crash because we have this tuple applied on a tuple matching applied on an integer. That's really nice.
Now, if you come from a dynamic world and I used to write code in a dynamic way, well, you know, sometimes weird things happen. Like, for example, I wrote that code here where I want to see how long it takes to execute a function. Now, this function is just returning an atom, so it should return pretty quickly. Yeah, so I'm testing this. I want to use it in the shell. I want to kind of see what is the output, how long does it take. Yeah? And I annotated the function to take no argument and to return an integer. Well, it turns out that actually I got it wrong. Yeah? Something went bad, and shell crashes with an error saying bad argument. Whatever I pass to format should be of type integer. Well, I actually thought it's type integer, right? That's why I made my annotation. So where's the problem? I take, well, the type checker I like, actually off the shelf, apply it, and, well, it does not flag any error, which is, you know, a little bit disconcerting. So, because Albert is the better Erlang programmer, I went over to him asking, what is actually happening?
So maybe let's take a look. We have some other tools in the ecosystem. What do they say? Oh, they all flag the error correctly. There's something wrong with this code. So yeah, but for other people, this is quite confusing. There are multiple tools. Some tools say this and some tools say that. So why?
Yeah, so the tool should just work, right? We have a language specification. We have a specification of how types and function annotations and so on should work. Shouldn't all the tools kind of spit out the same answer?
And for that, we will take a look at all the tools in our ecosystem and figure out what they are going to say. We have 4 tools right now. Everyone knows Dialyzer. It's a tool that only detects an error if it really crashes. If it doesn't find anything, it stays silent. So it chooses to have no false positives for that reason. We have Gradualizer, a research prototype. It's a static type checker, and it supports gradual typing. We have eqWAlizer, as used in the Erlang language platform. It's also basically based on gradual typing. It supports quite a lot of Erlang code already. And we have etylizer, a recent research project which is based on set theoretic types. So these are our contestants, so to say. And to check now on what part of the code bases they agree on, we took a look at the code bases of the tools themselves. So all these type checkers, they're tested. They have their own little 2 boxes for each tool, code that is supposed to work and code that is supposed to throw a type error or some warning or diagnostic or something. And these tools all have their little own worldview on what code should pass and where some other error is supposed to be thrown. And the question is now, if I pick any piece of code, will it end up in the same category of boxes across all tools? And the idea is, well, we take a tool, we combine these boxes together and see if they agree on all outcomes. The idea is quite simple to understand. In practice, it's a bit harder to realize because each tool has their own testing format and so on. And this is one of the outcomes of a paper we've published a few months ago in the Erlang workshop. But that's not really the point of the talk here. The point of this talk is to look at concrete examples where the tools disagree. So let's look at the test data first, what we managed to sample from. The Dialyzer test suite, we've selected under 100 cases. And this is because we had to decide which flags we use the tools with. And it's very difficult to decide, for example, for Dialyzer, which flags to use because it has so many flags. And because of fairness reasons, we said we will use every tool with its default flags to have at least somewhat of a fair comparison. The problem is with Dialyzer test suite, it's structured in a way that they have many tests for many different flags, and the subset of that uses default flags is quite small, which is a bit disappointing, but that's what it is. eqWAlizer is the most well-tested tool, I would say. It has a lot of test cases for almost all constructs, so we managed to extract quite a lot of test cases out of that, which also you have to keep in mind for later. It will bias a bit the results. And a few hundred test cases for etylizer and Gradualizer, which is okay, I guess, for language coverage. So keeping that in mind, we expected naively that we have quite a lot of agreement and a small subset of edge cases where the tool disagree, where we as a community will decide what to do on that. So this was the result. We have each tool is a bar, and it displays on the pass. Everything is agreeing. Everyone is agreeing. In red, a tool disagrees with some other tool's test case. We can see there's quite a lot of fails in that diagram, and which was for us a bit surprising. But let's say it positively, the tools agree on most test cases. At least 70% agree on it. That's more than nice, I would say.
Yeah, but 70% agreement means it's like 30% disagreement, right? And this is a little bit concerning because so the people who implement these type checkers know actually what they are doing. At least that's what I hope. Maybe as a short disclaimer, Albert is the main developer behind etylizer that we are developing across several universities. And yeah, we wanted to kind of see if our understanding is correct. And whenever we kind of come up with a case where we think actually our type checker is doing the right thing and another tool is disagreeing, it's kind of a really red flag for us to see what is happening and to understand what is going on.
Yeah, so these other 30% roughly, they're consisting of two categories. False positives, where the tool could complain, but cannot find the error because of it's not not powerful enough, or false positives, where the code is okay, it does not crash, but the tool complains anyway because the theory behind it is not powerful enough. So we want now in this talk go over a few of these categories and see when we've got a type error, what to do now, and we will compare these tools, what they have to say about each type of category we've identified. So let's cross-check against some examples. Dynamic function application. So in Erlang, we have lambdas, we have these little constructs where we can create anonymous functions and we can apply some arguments to those dynamic functions. And these functions have arities, and when the arities mismatch, a runtime error occurs. This is a test case from the eqWAlizer test suite, so this should fail, according to eqWAlizer. Let's see what the tool says. Every tool except Gradualizer correctly identifies that this test case should fail. And this indicates some general problems where Gradualizer is not being able to handle these local function definitions very well. So they're kind of hard in their theory. Let's take another look at a more involved example. Functions and case expressions, where we have a function foo. Let me see. We have a function foo, which maps something from A or B to type integer. We apply bar, which returns A and B. We pattern match on A and B and return 1 or 2. This is valid. This is not valid code, according to us. So this is from our test suite on the top right, because when applying bar, we want an integer, but we supply atoms. So this is a runtime crash, basically. Testing it against all tools, most type checkers find the problem. eqWAlizer says it's okay, maybe because the pattern matching on these case expressions is not powerful enough, or it's a bug, or something else. So right now, until now, the majority had basically the correct, let's say, opinion. Another case are imprecise standard library types, which all type checkers until now had to face at some point or another, including us and eqWAlizer. And they took the approach that this function, where a map that contains an atom key, and when we remove that key, the map cannot possibly have that entry, and this test case should fail because the output should not contain the mapping to A anymore. And this says, eqWAlizer says, we can do this, this should fail. The problem is the standard library annotation for map remove doesn't say anything about the contents of the map, and the other type checkers have no possibility of doing anything with that type annotation, and they just say, well, everything's okay. Just a small disclaimer, we just recently published our maps implementation, and these mandatory associations are work in progress, and this is one part of the not implemented bar, which will be fixed in later. So this is quite nice that eqWAlizer actually refines types by themselves, and hopefully at some point these refined type annotations make it into the Erlang standard library, and the other tools can benefit from that. Yeah, so next one.
Yeah, so just to test your own understanding and see if you know how type variables work. Type variables are actually pretty interesting and non-trivial to use correctly in Erlang. So we have here a function f that takes an x and something else and yields an x. And the annotated specification says it takes something of a type that, well, we actually don't care about, and a u, and returns a u. Who thinks this should yield type error.
Please raise hand. Okay, who thinks this should not yield a type error and should just pass?
Okay, almost. Yeah, almost 50-50.
Almost 50-50. That's interesting. Well, this is test case from the eqWAlizer test suite, and it is categorized as should fail. And interestingly enough, etylizer and eqWAlizer agree, and Gradualizer and Dialyzer says everything is okay. And the underlying reason behind that is the interpretation of the type variables. Up until recently, I would say, was not 100% specified because it was like an artifact of Dialyzer and so on and so forth. But I would argue that you will later see that the correct interpretation is with the eqWAlizer and etylizer tools, that this indeed should fail because these polymorphic functions should adhere to parametricity, and type of U can never be correlated with a type of T. So we would argue, again, with ELP, this should not pass. Now, these were all should fail cases, which means we have so far looked only at false negatives, and this means that sometimes tools cannot detect problems, but it's okay, we can't do everything. The other cases, false positives, where a tool complains even though the code is okay. We don't want that. Dialyzer just says, choose to never have false positives. As a type checker, as a typing system, we need to have false positives. So we need to constrain the amount of code such that certain class of errors will never occur. This means that sometimes code will fail, and this relates to the expressivity of the type system underneath. As a user, you should never encounter false positives because the type system should be so powerful that you will never encounter a case where code is correct and you don't expect a type error. So let's see a bit more involved examples. This one is quite simple. We have a function which takes a tuple and returns a union of tuples. And this is just distributivity on tuples, basically. Whenever we have a tuple having two atoms on the left side and a union, we can split them up on the right side and take the union apart, basically, to the outside. So we moved this union on the inside of the tuple to this union on the outside of the tuples. We have this law for both sides, so we can take apart the right side and the left side. And mathematically speaking, this is how you would write such a law. And all tools agree these test cases should pass. That's nice. So this code will not crash. It's okay. Going a bit further, what happens if we apply this law multiple times in a nested fashion? So they should still hold. Are these tools powerful enough to detect that this code should still not throw a type error? Let's see. We want to prove that we want to take apart these two unions into 4 unions on the outside by applying the distributivity law just 3 times. That's enough. Okay, let's prove it. We have our right side. We apply the distributivity on the left, merging these two. We apply the distributivity on the left for these atoms. And finally, we apply distributivity on the right to merge these parts. And in theory, we've proven that these two types are equivalent. As a test case, we have this in our test suite, where we say x is mapped to x, and we have 2 equivalent types as input and as output. This is valid code, and it should pass.
It's a very simple way to write the identity function. Right?
Yeah, one part of that. And Dialyzer doesn't complain, as always, that's nice. And we have a type system, but we are powerful enough to detect that these two types are equivalent. On the other case, eqWAlizer and Gradualizer, they don't get this nested application of distributivity correct, which is not bad, because distributive laws are really hard to get right if you don't have a sound and rigorous math background in your typing system. But yeah, that's how it is sometimes.
It's a bug, and knowing them, it will be fixed soon.
Yeah. The problem with distributivity is you have a lot of edge cases if you consider this case manually, and we don't. We just have this for free, basically. Another case is method overloading. So in Erlang type spec allows us to have multiple definitions, multiple function headers for the same method body. And this is nice because we can overload the same function with 2 different functionalities, mapping integer to integer and mapping atom to atom. So we can consider this method body of having the same type. This is a test case from us. Everything is okay because in this branch we process the integers, and in this branch we process everything else, and this is the atoms, mapping atom to atom. Again, method overloading is really a hard problem. And eqWAlizer and Gradualizer are not able to detect this. Etylizer can do, because we want to push the limits of the type system as far as possible by using these set theoretic types as background. So we've seen quite a lot of categories. Which type of tools, which tools should I choose now? And going through these examples, you should have gotten somewhat of an overview. Dialyzer is always good to use because it will never get in your way, but if it will complain, it surely is an error. So that's a nice thing of tool to have. Etylizer is based on a rigorous type theory, and it allows to type check quite a lot. And we have full reasoning implemented for patterns, guards, unions, method overloading, and whatnot. But not everything is rainbow and unicorns. It has a price. So right now, everything is quite slow and expensive. But we are at the point where we can start type checking single functions of modules, basically. And you can try out our tool for single functions and see if it has a type error or not. On the other hand, eqWAlizer integrated into LP can be, I think, for surely integrated in the most code bases, see the Erlang language platform, and is able, has some expressivity enough to cover most use cases, I think. So there should be no problem. Yeah. Best practice.
Yeah, so best practices, what should you do? Well, by all means, use a type checker, right? If you're happy with somewhat flaky research in progress, use etylizer. If not, have a look at eqWAlizer. Add type annotations to your code. This will help you at some point, even if it's just for documentation purposes, and try to make them as precise as possible. The better your type annotations are, the more you, your future you, your collaborators, and any upcoming tools can do with them. Make sure to understand how type variables work. From our experience, also looking at type annotations in the standard library, it's a common source of confusion and misunderstandings. Follow the type language spec, not the quirks of some tool. That's something we apply to. It's great that we have as Roberto said, some competition. Well, it's great to have more than one person checking once in a while the language specifications, because this should be actually the common ground on which a community builds a language and builds a tool. Yeah? It's interesting to come up with new ideas, but it should, fit with everything else. And it would really be a pity if the community would kind of scatter around and follow quirks of specific tools that, might change because it's just a temporary bug or something. The work on type checkers is definitely improving. If you have not used them yet, it might be a really good time to start to do so.
Yeah, coming back again to our overall results. Even though this diagram is just a few months old, this is already outdated, because this pace of improving typing in Erlang is accelerating quite fast, I would say, in the last few months and years. For example, for etylizer, we've cut down the not implemented part by 2/3, just binaries and some other parts are missing. So language coverage-wise, all tools are almost at the same pace. Dialyzer is getting improvements on what it can do in introducing nominal types and so on. eqWAlizer is constantly improving things that it can type check and not type check, so the bar will become smaller because it agrees with the test case from etylizer, making both bars higher up in the blue part. The only one thing, the Gradualizer will stay as a research prototype, I think, because it finished what it could do as far as I understood, and it's still nice to test against and see how other tools have improved so far. So, the conclusion.
Yeah, so keep in mind, Erlang's static typing tools are still, to some degree, opinionated. There are discrepancies between the interpretation of some of the specifications by the different type checkers. Some of them are intentional. We did not go into any details of, for example, how eqWAlizer treats numbers or so. This is specific, perfectly fine if you know what the tool is doing. But sometimes it's really helpful to understand at least a bit of the underlying theory to kind of, get why certain tools behave in a certain way. What we figured is that looking at these discrepancies is a great way to figure out weaknesses and issues with the typing specification and the type language itself. And we also would like to ask the community to help in getting both the specifications and the tools better. There's a lot going on in typeland. So we have new features like nominal types that are very likely to be introduced in OTP 18. It's a great extension, and really a pity that the presentation was not possible here today. The maybe types, dynamic, is all helping us to get our code bases nicer and better. If you looked at the types 10 years ago, 20 years ago, and did not like them, fair enough, things have changed. We also see that so from an academic point of view, we're really interested in getting the foundations kind of sound and complete. There are some changes to the interpretation of certain types. Like currently out, we have EP 71. That is about the type variables, as I mentioned. So remember the function that we saw in the beginning, where I claimed that TC should actually, or the test function should return an integer. Well, timer TC, the library module, is actually returning a tuple of time and value. So it will give you the measured time, but also the value that the function evaluation yields. And so we are not going into details as why our tool, etylizer, with the set-theoretic background, would interpret this as a correct type interpretation. It's somewhat not obvious. But flagging this with the OTP team, with the WhatsApp team and other interested people, we figured out that using type variables and subtyping on type variables as currently specified in the language specification, it's done in a way that actually is not true. People don't use type vars that way. We tend to use type vars as generics, because that's kind of what other languages imposed upon us. There will be a proposal, or there is a proposal to change this interpretation of type variables such that we can have, again, a very sound foundation to build upon and have the tools agreeing more.
Also, this EAP, there's also a place for feedback, to give feedback on the Erlang forums webpage. There's a forum post where you can just say your opinion and discuss this as a community together. So
the whole story of Erlang's type system and type language, type checkers, is not told yet. It's to be continued, and I'm looking forward to many exciting new ideas on the horizon, mailbox types. We already saw yesterday, so there is quite a few things going on and happening. We did not add them yet, but they should definitely be on that list here. So thank you very much. I hope you got some insights into how interesting, difficult, challenging static typing is, and make use of our tools for the best of your code base. Thank you very much.
Okay, thank you very much. I'll let, since we're into our coffee break, if people want to go have coffee, I don't know if anybody wants to ask one question maybe before we go. Oh, there's a couple questions. Okay. You got first.
Did you have any examples where one of the tools rejected a code example, and then when you did whatever the natural fix was, that made another tool go red instead, and so you were constantly toggling between upsetting a different tool?
Well, this will happen usually.
So if you want to apply the fixes that a type checker is kind of indicating or imposing upon you, yes, this could happen. Yeah, there will be errors that will be flagged by eqWAlizer and that won't be flagged by Dialyzer, and you change it. Dialyzer is, no false positives, so it will stay silent even if there are some issues. Yeah, but if you switch between different tools, yes. And we believe that this is exactly the right point to either label very clearly for the type checker that you're using what the limitations are, which is fair enough, right? Or flag it as a bug, right? It's still tools, right? So there can be bugs. And I would be careful. So what Roberto showed before was actually really great, that you can mark something as a fix me in order to fix that later, or as an ignore in order to ignore it because you actually don't like the change that you should do for whatever reason. Having this integration into ELP is really nice, because then you can kind of say, yeah, I know you're complaining, but I know I'm right, and that's it.
Cool. Thanks again. If there's any more questions, find each other, ask on Whova. But thank you very much.
Just one short advertisement. If you like Berlin, and I guess you like Berlin because you're here, and you like Erlang and Elixir, there will be a conference in March called BOP, which is about the best of programming, best of software development. Yeah, so it's a great smallish, so slightly smaller than CodeBeam, community event, and we're looking for people who want to give demos, give talks, presentations, give tutorials on the language of their choice, the framework they love and like. So have a look. You can also ask me. I'm very happy to see you again in Berlin, not only next year, but maybe even in between. Thank you very much.